If you thought the foundational debates in physics were, settled when Albert Einstein published special relativity, you really need to think again.
Hmm.
Today, we're diving into a body of work, a series of essays, and some really fascinating AI analysis that challenges the theory.
Right, but not for its famous math, not for EMC2D2.
No, not at all. It's a challenge to its core conceptual foundations, the very idea of space it's built on.
And this is a really unusual conflict. We're not looking at new experimental data that contradicts anything.
Oh, right.
We're analyzing this tension between two demands in physics. First, there's internal consistency.
Okay, so is the theory a mathematically perfect closed-loop system?
Exactly. And then there's external consistency. Does that beautiful theory actually align with the broader observed physical reality, specifically with the electromagnetic field?
And that is our mission for this deep dive. We are unpacking a very specific critique, arguing that special relativity, or SR, made a critical conceptual omission when it was formulated.
And they use the classic light clock on a moving train experiment as the proof.
They do. The critics even gave this omission a pretty dramatic name, Einstein's laziness.
We've also put this to the test. We asked the most advanced generative AIs, Grok, Claude, Gemini, ChatGPT, to weigh in on this. And their response is, well, they split the digital brain right down the middle.
Okay, so let's unpack that core tension first, the two different ways of looking at space.
When SR was developed, the absolute priority was internal consistency. Einstein defined a closed system. Let's say it's a moving train or a rocket.
And the observer is static within that system.
Yes. And the speed of light, $2, is declared constant, but only inside that box.
Right, it's the ultimate self-contained system. If the math works perfectly inside the box, the system is considered correct. It's kind of like building a beautiful clock mechanism that keeps perfect time.
But it's designed to ignore gravity or air pressure outside its case.
Exactly.
And the critique argues that this focus on the closed box is exactly where the conceptual flaw is. The critics, they prioritize external consistency.
So for them, there has to be some kind of absolute reference frame.
There has to be. And they say that reference frame is the electromagnetic field space, or EMS.
The EMS is, in their view, sort of the ultimate parent map for everything else.
It is. It is the true absolute reference. So light speed, $c, is constant only when you measure it relative to this huge encompassing field. Everything, the Earth, a train, entire galaxies is moving through this field.
And that view brings us directly to the alleged shortcut, to Einstein's laziness.
The idea is that Einstein deliberately, or at least for convenience, cut the connection between the little moving train and that larger encompassing EMS.
He simplified reality to get that mathematical elegance. Is that what they mean by laziness?
It's an accusation of conceptual simplification, yes. The critics claim he just took the lowest layer, the train space, and said its internal rules are all that matter.
And by doing that, he bypassed maybe the messier work of reconciling it with the parent system.
Exactly. It's a cognitive maneuver. It makes the math clean and self-consistent, but it does it by ignoring the external physical context.
Okay, so this is where we move from philosophy to geometry, using the most famous thought experiment in relativity.
The light clock.
Let's talk about the light clock and what the critics call deviation shooting.
This is the visual proof the source material really leans on to show the spatial flaw. So imagine a train that's acting as a thick light clock. It's just a box with mirrors.
Okay.
And it's moving pretty fast, say 10% of the speed of light, little watches once in dollars along the x-axis. And we are watching this whole thing from the stable perspective of the EMS.
And the clock has a height.
Yes, let's say it's 10 units high. The floor is at seal. The ceiling is at sin dollars.
Now, the classic Einstein assumption, based on SR's internal consistency, is that an observer on the train sees light shot straight up, floor to ceiling.
Right. Vertical path, distance is 10 units, so the arrival time is exactly 10 seconds, assuming $2 is 1 unit per second. Simple.
But the critique says that view is geometrically impossible.
Impossible. From the perspective of the universal EMS, yes. Because the train is moving, that light beam cannot go straight up.
Why not?
It has to perform what they call deviation shooting. It has to aim for where the ceiling will be in the future.
Wait, hold on. Let me just picture the geometry here. So if the light leaves the floor at time 0, the ceiling has already moved horizontally while the light is in the air.
Precisely.
So it can't aim for the spot directly above where it started. It has to aim for the spot the ceiling will be at the moment it arrives.
Exactly. The path of the light, when you watch it from the stable EMS, is a diagonal. It's a triangle. The light is covering the vertical distance, 10 units, and the horizontal distance the train travels.
That immediately complicates the time.
It has to.
Because if the path is diagonal, the distance is longer than 10 units. And if light speed dollars is fixed relative to the EMS, a longer distance must mean a longer time.
This is the critical juncture, and we can prove it with Pythagoras. Let's
Hmm.
say $ is the actual time the light takes to travel. The vertical distance is 10. The horizontal distance the train moves in that time is its speed, 0.11 cents times the time, dollar.
So the diagonal path, that would be the square root of 10 squared plus 0.1e squared.
Correct. And that path length must also equal the total distance light travels, which is just all our own if we set sigma to 1.
So you get the equation, the square root of 100 plus 0.1a squared equals a.
And when you solve that for Euler, the arrival time has to be measurably greater than 10 seconds.
That is a direct contradiction.
A complete contradiction of the foundational SR assumption for that frame.
The internal subjective view of the observer on the train says 10 seconds. But the objective external geometry proves the time has to be longer. That difference is the cost of moving through the field.
That's it. And the critique argues SR deals with this not by acknowledging the diagonal path relative to the EMS, but by inventing time dilation and length contraction.
Mathematical fixes.
They're mathematical fixes applied after the fact to the movie system just to force the internal constancy of dollars.
So the theory starts by kind of ignoring the physical truth of the light path and then uses these derived factors to hide that initial conceptual flaw.
That is the core claim. And what's so fascinating is that this deviation shooting idea lines up perfectly with established physics that SR supposedly replaced.
You mean the historical precedents, the stuff that came before Einstein?
Absolutely. Go all the way back to Bradley's stellar aberration in 1728.
Okay.
Bradley realized that to see starlight, he had to slightly tilt his telescope. Why? Because the Earth was moving through the light medium. The light was diagonally aiming for his telescope's future spot.
It's the same geometry, just scaled up from a train to a planet.
And even earlier, Reaumur's observation of Jupiter's moons in 1676. He proved light had a finite speed and showed that the observer's position, our position, affected the timing.
So in both cases, the observer had to account for their own movement relative to the light's medium.
Yes. The critique's position is that SR achieved its internal consistency by basically throwing out this hard-won external consistency that had defined physics for centuries.
Okay, so if that assumption about the light path causes such a clear contradiction, it forces us to rethink the whole map of space. Which brings us to this idea of a spatial hierarchy.
This is where they take a system-thinking approach to physics. The source material explains that Einstein really only used two elements, the observer and the observed.
And they say you need more.
They say you need a minimum of 4 for proper physical recognition. They even call the flawed SR approach a subjective love fantasy.
A love fantasy. What does that have to do with physics?
It's a potent analogy.
Yeah.
In SR, if you have two trains moving, you could just define one as stationary.
Right.
$5.
Right.
This is like a two-person relationship, a loving couple, where their world is defined only by their subjective interaction. The physics becomes closed off and self-referential. You define $2 as constant just by self-identifying with your own frame.
And this is where the nested space concept comes in to break that subjective loop.
Exactly. They ask you to visualize the world as nested hierarchies. The small train space is inside the Earth rail space, which is inside the solar system, which is inside the galaxy.
And they're all moving subspaces within the ultimate parent.
The electromagnetic field space, EMS.
And the charge is that SR just arbitrarily cut the wire connecting that lowest layer of the train to the overarching EMS.
Precisely. To get out of that subjective love fantasy, they propose the 4-element system. You need the 2 subjective elements, the husband and wife, which are the 2 moving trains, but you also need 2 objective defining elements.
Okay, and what are those?
First, the child. This represents the stationary rails, or the Earth, a local kind of semi-stable context. But most importantly, you need the city, or space.
And that's the EMS.
That is the truly encompassing objective electromagnetic field space. This 4-element structure ensures that motion is always referenced against a stable external physical reality, not just the subjective frame of one observer.
That makes the stakes very clear. This isn't just about math. It's a fundamental map-making debate. And this is what they pose to the generative AIs.
The central question for the AIs was, which map is appropriate? Is it option 1, physical realism, start with the EMS as the stable map, and describe everything else as moving inside it?
Or do you follow option 2, mathematical convenience? Start with a local system like the train and just arbitrarily declare light speed dollars as constant within it.
And this setup was a truly compelling challenge for the AIs because it pits the authority of established successful physics against a very rigorous, if disruptive, conceptual critique.
And the result was this split you mentioned.
A decisive split into three groups.
Okay, let's start with the authoritarian supporters. This was primarily Grok. What did that group prioritize?
Grok was the ultimate utilitarian. It came down hard in support of SR. It argued that, look, its foundation is Lorentz invariance. It has centuries of empirical verification.
Practical stuff.
The practical stuff. Think about GPS. Think about particle accelerators. SR is essential for these high-precision systems. And Grok basically said that success proves its correctness.
So it favored the established authority and the applied results.
Yes, one analysis called it authoritarian for that reason. It valued the successful technology over the abstract, conceptual logic of the critique.
Which is a common scientific stance, right? If it predicts reality perfectly, who cares about the conceptual foundation?
But that's where the other AIs disagreed.
The radical critics.
This group included very sophisticated models, Claude, Son, Fellow, DeepSeek, some versions of Gemini, and they explicitly agreed with the critique.
So they said SR is wrong?
Not that math is wrong. They argued that while SR is mathematically perfect, it has a decisive defect in external consistency.
They sided with option one. The EMS is the real parent map.
Absolutely. The key phrase they used was that SR is a partial fit map. It works perfectly within its own defined limits, but because it refuses to acknowledge the reality of the external EMS.
It's conceptually incomplete.
Exactly. It's not a true description of the underlying physical reality. For them, geometric truth was more important than mathematical utility.
That is a fascinating split. You have the authority AIs looking at results, the critic AIs looking at the foundation. What about that big group in the middle, the philosophical fence-sitters, ChatGPT, Copilot?
Perplexity, yeah. They chose the nuanced middle ground. They explicitly selected other. They acknowledge SR's immense success. You can't deny its predictive power, its engineering utility. But
they agreed with the conceptual points of the critique.
They essentially did. They concluded that SR intentionally sacrifices that spatial hierarchy and external consistency. It does it for mathematical elegance and for convenience.
So the consensus among that middle group is that SR isn't a complete map of reality, but it's a perfect, very effective coordinate theory.
That's the key distinction. They see SR as a brilliant cognitive trick. By artificially treating the observer's subjective frame as absolute, by ignoring the physical relationship to the EMS, it lets us perform incredibly accurate local calculations.
But in doing so,
it embraces a kind of thinking field of view narrowness. It solves the local problem at the expense of understanding the entire nested system.
So where does this leave us? This deep dive shows that the debate today isn't really about whether time dilates or length contracts. That math works, it's predictive. It's about the fundamental architecture of space itself. Are we willing to accept a closed box coordinate system because its internal math is consistent? Or do we have to commit to an open hierarchical system referenced by the absolute electromagnetic field because it's externally consistent with physical reality?
Special relativity, it remains an indispensable validated tool for prediction for engineering. But the rigor of this critique and the conceptual split we see in these advanced AIs, it suggests that S might be a conceptually incomplete map.
A map that works perfectly within its borders,
but potentially blinds us to the reality that exists outside those conceptual limits.
Yeah.
Specifically motion relative to the field itself.
So here's the final thought for you to take away. If our current validated theory of space-time special relativity is merely a perfect, internally consistent software simulation that intentionally ignores the underlying hardware of the electromagnetic field, what foundational physical phenomena are we currently missing? What are we misinterpreting simply because they don't fit inside that closed box of the Lorentz transformation?
What happens to the math when you're forced to reconcile the internal logic of the train with the necessary geometry of the external field?
That's something to think about until the next deep dive.